let's talk about risks from plate boundaries. Looking at our map, the blue is the ocean, the gray is the continent land. The red lines here are convergent plate boundaries. Like this one here is the boundary between the Pacific plate and the North American plate. The orange are transform boundaries, like when the two plates, in this case the North American and the Pacific, are rubbing against each other, sliding past one another. That's a transform boundary. And then when they are pulling apart like this, like in this case the Nazca plate is going this way and the Pacific plate is going this way, then we have a divergent boundary. If we are inside a plate, away from the boundary, that's where we are safe from earthquakes and volcanoes. So this is the safest place. If you'd like to build a nuclear power plant, it's better to build it here than here. Or here. This is Japan, between the East China Sea and the Sea of Okhotsk. This is where the 2011 Tohoku earthquake and tsunami happened, and the big Fukushima nuclear power plant disaster. Now J is also in the middle of a plate, so that's safe. M is in the middle of a plate. Now, divergent boundaries, that's the plates moving away from each other, breaking the crust in between. As they break the crust, magma is going to come out of it. So we get volcanic activities in divergent boundaries. These volcanic activities most of the time are going to be like simple oozing of lava. That's what it's going to amount to. It's not going to be huge mountainous volcanoes for the most part. That's divergent boundaries. And divergent boundaries can happen in the oceans, or they can happen in land as well. And when they happen in land, as they keep progressing with the years, where they make that break, they form new oceans, new seas and oceans. The earthquakes that might happen in divergent boundaries are small, shallow, and low energy, essentially unmentionable. You can be sailing on top of a divergent plate boundary and not realize that there is an earthquake. They are so tiny. So we don't talk of earthquakes generally when we talk of divergent boundaries. Now, transform boundaries, on the other hand, think of the San Francisco large earthquake. That's what we get out of transform boundaries. Large earthquakes. We don't get anything else but large earthquakes. No volcanic activity. Now for convergent boundaries, we get large earthquakes. Think of a head-on collision between cars. That's the most destruction. Same here. Most destruction between the plates, so that's large earthquakes. And that's going to happen no matter where you are in a convergent boundary. It's going to be a large earthquake. But if both sides of the boundary are ocean, if it is oceanic, along with the large earthquake, we are going to have volcanic islands. So we have volcanic activity and subduction as well. Subduction meaning one plate is going to go under the plate that is less dense than it. And it is the subduction that's most of the time responsible for lifting part of the plate, and that's what's going to help build islands. Now, if it is oceanic continental, like in G here, that's what's going to get us volcanoes, large mountain volcanoes. Let me see if I can show. This is the example we talk about in terms of large volcanoes. This and this. These are the Andes volcanic mountains in South America, in the western side of South America. You see how sharp they are, how elevated they are. That's the kind of volcanoes that we get out of oceanic continental convergent plate boundary. Now, if both sides are continental, like in D here, also like when it is oceanic, the one that's more dense than the other is going to sink below the less dense one. So we also have subduction. So it's going to raise the land, but this subduction, when we are both continental, is not going to result in volcanic activities. It will result instead in large mountains. Like here in D, this is India, part of China here. So that's where we see the Himalayas that are due to that continental convergent boundary. So oceanic convergent, oceanic continental convergent, whenever we have ocean, we have volcanic activity and large earthquakes. But if both sides are continental, we get large earthquakes and mountains. Here is a picture of the mountains. This is the Himalayas being looked at from the top. That's the way they look from the top. That's convergent boundary, continental. Okay, let's practice this a little bit. Which plate boundaries result in mountains? Only one is going to be here when it is continental, convergent. Convergent boundaries that are continental, whenever we have land in both sides of the boundary, we get mountains. Which plate boundaries result in volcanic activities? Remember, it can be a convergent boundary when at least one of the sides is ocean, or divergent boundary, they are going to be smaller volcanic activity, but they are still there. So divergent boundaries, we have volcanic activity, and convergent boundary when at least one of the ends is oceanic. So it can be oceanic or oceanic continental. Which plate boundaries result in small earthquakes? Only divergent boundaries. Transform boundaries and convergent boundaries, both of them result in large earthquakes. Which plate boundaries result in large earthquakes? I just talked about it. So convergent boundaries, all of them. It does not matter where, if they were both sides ocean, if it is oceanic, or oceanic continental, or continental, all of them will result in large earthquakes. Transform boundaries also result in large earthquakes. Remember the San Francisco earthquake. In which areas there is a low probability of having earthquakes or volcanic activities? Now, to have low probability of earthquakes or volcanic activities, you need to be away from the boundaries. So that's places like J, A, M,